One of the critical jobs when it comes to degreeing the camshaft is to find true top dead center, or TDC for short. Remember, this is the point where the piston has reached the top of the stroke on the compression stroke. Now, a lot of novice engine builders think incorrectly that we can just find this by relying on the factory timing marks fitted to the engine. Unfortunately, these timing marks may often be several degrees inaccurate, and we can't rely on this in order to get accurate degreeing information when we are dialing in our cams. Now, for our module today, we're going to be using our Honda B18C engine, and we're going to be looking at 3 different techniques of how we can find true top dead center. The products we're going to be using are on the workbench here, and we have a positive stop which we can use to locate in the spark plug hole, and this will stop the piston from moving up the bore. We've also got a deck plate here which can be fitted once the cylinder head is removed. This is a common technique if we're degreeing a cam on a pushrod engine such as a V8 for example. We've also got our dial indicator and an extension for our dial indicator. We're going to be using this down through the plug hole on our B18C. And finally, I've also got a little pointer that we've made up here. I just want to talk about that pointer. Obviously, once our degree wheel is fitted, we're going to need a pointer that's located on the engine block and is actually going to point at the degree wheel. For some engines, we can buy commercially available pointers, and these are adjustable. In my opinion, though, that's certainly not necessary. Generally, what I do is simply make up a pointer out of a soft piece of wire that's easy to bend either by hand or using a pair of pliers. In this case, we are going to be simply using a piece of 1.6mm diameter TIG welding steel welding wire. This is relatively cheap and easy to source, and we can simply cut off a section as required and use it to fashion a pointer. One thing we do want to keep in mind when we are making a pointer though is that it is important to sharpen the end of that piece of wire. This again just gives us slightly more precision when we are reading the degree markings on our degree wheel. Now for this example, I am going to be locating our pointer on a convenient bolt hole on the cylinder head. It doesn't really matter where we locate the pointer. All we're looking for is a convenient bolt hole that we can bolt that pointer down onto. We've got our engine currently timed relatively close to top dead center on the compression stroke for number 1 cylinder, and we've just simply found this at the moment using the factory timing marks. These should be close, but as we've discussed, they're unlikely to be perfect. So let's go ahead and we'll bolt that pointer on. What we want to do is try and locate it currently so that the pointer is pretty close to our TDC mark on our degree wheel. Okay, so we've got our pointer bolted on, and we can see that it's relatively easy to manipulate the pointer by hand. So what I'm going to do for the moment is just get the pointer pointing directly at our TDC mark, and this is where we can start. Okay, so now we're going to go through the techniques that we can use to actually find true TDC and adjust our pointer. What we're going to do is start by using a dial indicator, and we're going to locate the dial indicator down the cylinder on number 1, and we're going to be finding where that dial indicator comes up to the highest point. Now, this will be TDC, but we can't directly use that value because there is some dwell around top dead center where the piston sits at or very, very close to top dead center. So what we're going to do is fit our dial gauge. We're going to find the point where the piston is at the top of the stroke. We're going to zero our dial gauge, and then what we're going to do is find a point where the piston is 50 thou down the bore on both sides of TDC. We're going to be finding that point on our degree wheel, and then we'll know that true top dead center is exactly between those 2 degree markings. So let's go through that process now. In this instance, the dial indicator on its own is not going to be very much use because it's not going to be able to extend down the cylinder and touch the top of the piston. So what I'm going to use here is an extension that will allow the amount of reach that we need. So we just can screw that into our dial indicator, and then we can locate the dial indicator down the bore. When we are locating our dial gauge on the top of the piston, it is important to make sure that the extension for our dial gauge is not going to be contacting the spark plug hole. We want a direct contact straight down onto the top of the piston crown. Okay, with our dial indicator now fitted, remembering we are at top dead center right now, what we're going to do is use a strong arm on our crank pulley, and we're going to just rotate the crankshaft backwards and forwards across top dead center so we can find the point of maximum lift, and we're going to zero our dial indicator at this point. We see that as we move either side of our TDC point on our degree wheel, the dial indicator moves down. So what we find is that maximum lift is occurring around about this point here. So what we're going to do is just simply turn our dial indicator until we are zeroed. Now, it also doesn't need to be particularly accurate at this point. All we're looking for is a point equal distance down the bore on each side of TDC. Now that we've done this, let's move our crankshaft back until we are 50 thousandths of an inch down the bore. We want to do this reasonably smoothly and gradually so that we can creep up on the exact measurement. So we're right there now. And what we want to do is take note of our degree reading on our degree wheel. In this case, we are sitting on 16 degrees. So with that noted down, we can then go to the opposite side of TDC. And we're looking again for that same point, 50 thousandths of an inch down the bore. At this point, we see that our degree marking is approximately 8 degrees there. So we have 16 and we have 8. And what we know is that true top dead center is going to be exactly in between those marks. A really easy way to find that is simply to use a calculator. We want to add those two values together and then divide them by 2. So let's do that now. So if we enter our values of 16 plus 8, and then we divide that by 2, we find that we should have our pointer reaching 12 degrees each side of TDC. So what we're going to do is simply adjust our pointer. In this case, all we want to do is just bend our pointer slightly by hand until it is pointing at 12 degrees. But first of all, we want to check that we are still sitting at the right point, 50 thou, and I'm just going to move my pointer by hand. It's relatively easy to manipulate our pointer. We'll get it onto our 12 degree mark. And now we can go the opposite side of TDC. And again, we're just looking for that 50 thou point. Okay, so we see that we've come exactly to 12 degrees. So we know that we've got an equal measurement on both sides of TDC. So our pointer is now aligned. We can now remove our dial gauge and continue. Often this will be an iterative process that may take you 2 or maybe even 3 attempts to get right. It really is important to take the time to do this precisely because all of your cam degreeing will rely on this particular step. The next technique that we're going to look at is using a positive stop that's screwed down the spark plug hole that prevents the piston from coming up past top dead center. For this method, we're going to use a commercially available positive stop. This has the same 14mm thread as our spark plug hole, and it's also adjustable, and this is convenient because we can adjust it to suit different compression pistons to allow the piston to come up close to top dead center but not move past it. Now, if you don't have a commercially available positive stop like we've got here, another way of doing this is to modify an existing spark plug. What we can do is cut the electrode off the spark plug and carefully weld a small section of steel bar to extend the spark plug and achieve exactly the same result. And before we screw our positive stop into our Honda engine, what we're going to do is just move the piston back from top dead center around about 30 degrees. This will just allow us to fit the positive stop to the engine without any chance of it currently contacting our piston. So we're going to screw the positive stop back out. So again, there's no chance of it contacting the piston, and we're going to screw this into our engine. Okay, so we've got our positive stop fitted now, and what we want to do is bring our piston back up towards top dead center. When we are doing this test, we generally want to be relatively close to top dead center. So what I'm going to do is I'm going to bring our piston back up to about 15 degrees before top dead center, and then just gently using a screwdriver, we can tighten down that positive stop. We just want to very gently move that down until we feel it contact the crown of the piston. So with our positive stop now screwed down against the crown of our piston, we can notice that if we try and rotate the crankshaft towards top dead center, that we can't get any further than we are now. This is because the piston is now contacting that positive stop. So when we take our reading, what we want to do is apply a bit of load to make sure that we are loaded against that positive stop. It is important, of course, that we don't apply excessive load to our strong arm. This could end up damaging the crown of the piston. It's also really critical, particularly if you are performing this task with the engine still fitted to the car, that the ECU or whatever is controlling the engine, as well as the starter motor, is disabled. So there is absolutely no chance of the engine being turned over by the starter motor. This would result in instant damage to our engine. So now we've got our positive stop fitted and we've come up against that positive stop. We want to repeat the same process we've just looked at. What we're looking at is our markings on each side of TDC. So in this case, we can see that we're sitting on 15 degrees. And what I'm going to do now is rotate the crankshaft through until we come up on top dead center from the other side. Now again, as we're coming up towards top dead center, we know we're going to be coming up against that positive stop. So we just want to move the crankshaft smoothly and slowly. Okay, so we've just contacted the positive stop there. Again, before I take my reading, I am applying a small amount of load to the crankshaft to make sure that we are positively contacting that stop, and we'll take our reading, which in this case is 22 degrees. So now the process we go through is exactly what we've just looked at. We want to add those two numbers together, and we want to then divide them by 2. If we take our first reading of 15 degrees and we add 22, we'll divide that by 2, and we know that we want to align our pointer so that it is displaying 18.5 degrees. So let's just manipulate our pointer now until we've got that reading. Okay, so we've got our pointer sitting at 18.5 degrees, and what we want to do now is just double check our measurements. So we're going to rotate the crankshaft around, come back up on our top dead center again from the other direction, come up on our positive stop, I should say, and we'll make sure that we are still seeing 18.5 degrees. Okay, so we can confirm there that our timing mark is still 18.5 degrees. So again, we've found true TDC exactly midway between those 2 points that we've got. We can now remove our positive stop, which is an essential task. We must make sure that that positive stop comes out of the engine again, just to prevent damage, and we can continue with our degreeing process. The next step we're going to have a look at is how we can use a stop placed across the top of the engine block with the cylinder head removed to achieve the same effect. With the cylinder head now removed from our B18C Honda engine, we've also relocated our TDC marker or pointer. Now in this instance, what we're going to do is use a positive stop that can be bolted across the deck surface of the engine block, and this essentially just straddles the bore, and there is an adjustable stop in the center which we can wind down until it stops or touches the piston crown. So we're essentially achieving exactly the same as what we just looked at with our positive stop located in the spark plug hole, only this time this is useful if we have an engine where we're degreeing the cam with the cylinder head or cylinder heads removed. Now, while we are using a commercially available product for our example here, you could easily fashion a similar product out of a piece of steel bar, provided that it's solid enough and stiff enough that it's not going to deflect as the piston comes up and contacts it. So what we're going to do now is we've moved our piston down slightly from top dead center. We've moved down around 30 degrees here, and we're just going to locate our positive stop across the top of number 1 piston. And we want to be careful to make sure that our positive stop is located very close to the center of the piston crown. If it's offset, then it can end up being affected by the rock of the piston in the bore. What we're going to do now is we've got 2 sleeves. These are just going to locate over our ARP studs, or alternatively you could also choose to use a shorter bolt for the purposes of this task. And we're now just going to wind our ARP nuts down on our studs, and we're just going to tighten this down. It doesn't have to be overly tight, we just simply want to make sure that it's not going to move around as we bring the piston up towards top dead center. Okay, so with our positive stop located now, we've got our adjustable stop in the center also loosened off. What we can do is bring our piston up a little bit closer to top dead center. So we're going to bring this up to around about 15 degrees, and we can just loosen our stop off to allow the piston to come up there. And where we need to locate this is going to depend on our piston design. In other words, whether we've got a piston with a dish or a piston that has a raised crown on it. Okay, so we're up to around about 15 degrees now, and what we can do is just lock off our stop, and this will just simply make sure that it doesn't move while we're going through this process. Okay, the process we're going to go through now is exactly what we've just looked at in our other 2 examples. What we want to do is come up towards top dead center, and again just apply a little bit of pressure. We can see that we're at 16 degrees before top dead center in that location. We'll come around the other way, again just slowly coming up towards top dead center. And we've got a value this time of 13 degrees. So what we're going to do is put those 2 numbers into our calculator. 16 plus 13, we're going to divide by 2. And we know that we want our marker, our pointer, located at 14.5 degrees. So we can go through and we can do that. We'll just manipulate our pointer so that it is pointing at 14.5 degrees. Okay, with our pointer now at 14.5 degrees, we'll just go through and we'll double check. We'll rotate our crankshaft back around. So we come back up on TDC again and make sure that we're getting the same value. And we can see we've got 14.5 degrees. So at this point, we've looked at 3 different ways of finding true top dead center, remembering that once we've gone through this process, true TDC is exactly halfway between those 2 points. We're now set up to begin our actual degreeing process. That was just one of the modules taken out of our cam degreeing course. If you're interested in learning how to correctly degree the cam or cams on your engine, then this course is perfect for you. You'll learn about the different styles of valve train actuation used on various engines and how the cam timing is measured and adjusted. You'll learn how to read a camshaft spec sheet and what details you'll need in order to accurately degree your cam. You'll learn what tools you'll need to degree your cam and how to install them and set them up on your engine. You'll also learn all of the practical skills you'll need to know, such as how to find true top dead center, how to read a degree wheel, and how to check piston to valve clearance. Finally, you'll learn the HPA 6-step process, which can be used to accurately degree the cam timing on any engine, regardless whether it's a pushrod V8 or a quad cam V12. Once you've learned this 6-step process, you can watch it being applied on real engines in our library of worked examples. If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.